So we're going to do the test 3 review solutions and work them out for you. So the first set of problems asks us to find the x and y intercepts. So for problem number 1, they give us 4x minus 5y equals 20. So we want to remember that to find the x and y intercepts, we need to set both x equal to 0 and y equal to 0. So let's find the x-intercept first. So recall the x-intercept is where the graph crosses the x-axis, which means y would have to be 0 in that case. So I'm going to write here, put y equals 0 in. So 4x minus 5 times 0 is going to be equal to 20. So 4x minus 0 equals 20 because 5 times 0 is 0. So then 4x is going to be equal to 20, and we'll divide both sides by 4, which tells us x equals 5. So the y-intercept is going to be the point, 5 for the x, 0 for the y. The x-intercept that's what the x-intercept is. For the y-intercept, we're going to do the same thing. We're going to set x equal to 0 this time because we're worried about crossing the y-axis, and so when we cross the y-axis, that's when y is equal to 0. So we're going to have 4 times 0 minus 5y equals 20. So 0 minus 5y equals 20. Minus 5y equals 20. Divide both sides by negative 5. And y is going to be negative 4. So the y-intercept is the point 0 for the x, negative 4 for the y. So we're going to do the same thing for the next couple problems. So problem number 2 gives us y equals 3x minus 4. So again, the x-intercept, that's going to happen when y equals 0. So 0 is going to be equal to 3x minus 4. This time I'm going to add 4 to both sides. So 4 is going to be 3x, divide both sides by 3. So x turns out being equal to 4/3, which means the x-intercept is 4/3, 0. And the y-intercept, again, that's when x equals 0. So y is going to be 3 times 0 minus 4. So y is going to be 0 minus 4, or y is going to be negative 4, which makes the y-intercept the point 0, negative 4. So that's the y-intercept. And the thing to notice here, actually, is that up here in the original problem, see how there is a minus 4 here? Because the original problem started out solve for y, I actually could just pull off the y-intercept as that number. But you don't have to remember that because you can always do this. This method down here where I plug in x equals 0 to find the y-intercept, that always works. So we're going to do some more of these. So problem number 3 gives us x plus 5 equals 0. So when we go to find the y-intercept, or the x-intercept, we're going to set, again, y equal to 0. Now notice there's no y here to put in. So x plus 5 equals 0. Subtract 5 from both sides. So x is going to be equal to negative 5. And so the y-intercept, I keep saying the wrong one. So the x-intercept is negative 5, 0. And now when we go to find the y-intercept, we're going to plug x equals 0 in. And so when I go to plug x equals 0 in, I end up with the following. 0 plus 5 equals 0. So 5 equals 0. And now that is not a true statement, right? So what that means is there is no y-intercept. And that makes sense because this line up here is actually a horizontal line. So it's not going to cross the y, not going to cross whoops, I said that wrong. This line here is a vertical line, which means it's not going to cross the y-axis. So problem number 4, y minus 5 equals 0. So the x-intercept, again, we're going to do the same thing. It's going to be when y equals 0. So 0 minus 5 equals 0, which gives us negative 5 equals 0, which again, that's not a true statement. So it means that there is no x-intercept. And to find the y-intercept, we're going to set x equal to 0. So there's no x here, so we're just going to have y minus 5 equals 0. We'll add 5 to both sides, and we end up with y being equal to 5. So the y-intercept is 0, 5. So we'll do one more of these. So 4x plus 3y equals 24. So again, we're going to do the exact same thing. The x-intercept we're going to do by setting y equal to 0. So 4x plus 3 times 0 is going to be 24. So 4x plus 0 equals 24. So 4x equals 24. Divide both sides by 4. X is going to be equal to 8. So the x-intercept is going to be 8, 0. The y-intercept we get by setting x equal to 0. So, get crazy line going on here sometimes if I don't watch where my hand is. Sorry about that when that happens. So when x equals 0, we're going to have 4 times 0 plus 3y equals 24. So 0 plus 3y equals 24. Divide both sides by 3. So y is going to be equal to 24 over 8. So that means the y-intercept is 0 for the x and 8 for the y. So now we're going to move on to a new type of problem. And in these types of problems, we're going to graph lines. So problem number 6 is y equals negative 1/2 x plus 3. And so this line here is already in what we call is in y-intercept form. So this 3 right. Okay, so number 6 is y equals minus 1/2 x plus 3. And so this is in slope-intercept form. So if you notice that here I have a 3, this is the y-intercept, and here I have the slope of minus 1/2. So those are the things that are going to be key to graphing this. So we need the y-intercept, and then the minus 1/2, that's the slope. So I'm going to make here a graph that we can draw this on. Just give it a couple lines here. And so the first thing I'm going to do is I am going to plot the y-intercept. So I'm going to go here, I'm going to put a dot at the 3. And then the second thing I'm going to do is I'm going to count the slope. So I'm going to go down 1 because it's negative. So since the slope is negative, then that's what's telling us we want to go down. If the slope was positive, we would go up first. So negative slope, so we're going to go down 1, and then we're going to go to the right 3. So no matter whether you go up or down, you're always going to go to the right. So I went down 1 and to the right 2. So down 1, right 2, and I'm going to put another dot there. So we'll make that dot green since it's the slope dot. And then all I'm going to do is connect these two dots to make my line. And so we're going to do that again for some more problems. So problem number 7, y equals 3x. Now, if you notice here, I only have the part with the x, which means I only have the slope. Right? And I'm going to leave some room under that 3 there for a second. So that's the slope. Up here in this problem, my slope was a fraction, so it was easy to think about going up or down some number and then to the right a number. This 3 here, it's not a fraction, but I can easily turn it into a fraction by putting it over 1. And then over here, we had that y-intercept, but down here, I don't have anything else, so I can think of it as plus 0. So that 0 is my y-intercept in this case. So again, I'm going to make my axis. And what I'm going to do is I am going to put a dot at 0 because that's my y-intercept. And then I'm again going to count my slope. So this time it's 3 over 1 and it's positive, which means I'm going to go up 3 and then I'm going to go to the right 1. So we're going to go up 1, 2, 3, and then to the right 1. And that's where I'm going to put that dot, that next dot. And then again, just like before, I'm going to connect my 2 dots with a line. So number 8. So we're kind of in the review sheet here getting to see all the different types that you saw in ALEKS when you were doing the work. And so in y equals 2, in this case, we don't have the x part. So there isn't the part with the slope. So there isn't the slope part here. So if you go to look at it, then what we have to do is all we have is the y-intercept. So I have the y-intercept because I don't have that x part, I don't have the slope. But when you have y equals a number, what that means is you have a horizontal line at that number. So if I draw myself a little axis here, again, that y-intercept is here at 2, and I don't have any slope, so slope is 0, and so it's a horizontal line, right? So horizontal lines have slope equal to 0. And we're going to do a problem that's a vertical line too in a minute. But we're going to do couple other just regular old plain graphing ones first. So y equals 2x minus 3. So in that case, again, it's already in slope-intercept form, right? So this is the intercept. So the y-intercept this time is a negative number. That's okay. And here's the slope. And again, I can think of it as 2 over 1. So again, I'm going to make my axis. And on the test, we'll be giving you, whoops, let me move that back. On the test, we'll be giving you an axis to look at. So it's not a problem. You're not going to have to draw this grid, is what I'm trying to say. So down here, you have negative 3. That's the y-intercept. And then again, our slope here is positive 2 over 1. So we're going to go up 1, 2, and to the right 1 spot. So that's where I'm going to put that next point. It went up 1, 2, and to the right 1. And then I'm going to connect those with a line. I mean, sometimes I draw one part of the line and then I draw the other part of the line just to kind of get it to look a little nicer. But that's good enough. And let's see, on to number 10. Now, number 10 looks a little weird because it says 4x minus 5y equals negative 20. And this one is not in slope-intercept form. So the first thing I'm going to have to do is solve for y. So I'm going to subtract 4x from both sides. So minus 5y is going to be, now notice the minus 4x and the minus 20, they are not common terms because this one has an x and this one doesn't. So I can't combine them together. So we're just going to get minus 4x minus 20. I personally like to write the x term first because in my brain I'm trying to get it into that y equals mx plus b formula. And so this sitting here as the first part, then it's easier for me to remember, oh, that's the slope. So now what I'm going to do is I'm going to divide by negative 5. And so dividing by negative 5 means I actually have to divide by negative 5 on both of these sides, on both pieces on the right-hand side. So y is going to be equal to, now I have negative over a negative, so that's really going to be a positive. Same thing here, negative over a negative is going to be a positive. So I end up with 4/5 x plus 20 divided by 5 is 4. So 4/5 x plus 4. And again, if I draw my line here, put a couple more tick marks on it for good measure. Might even need a couple more. Okay, so again, remember this plus 4, that's the y-intercept, right? And this 4/5, that's the slope. So I'm going to put a dot at 4, so 1, 2, 3, count up here to 4. And then the slope says that from here I need to go up 1, 2, 3, 4, and then over 1, 2, 3, 4, 5. Excuse me, 5. So I'm going to put that in green. So again, we're going to go up 1, 2, 3, 4, and then to the right 1, 2, 3, 4, 5. And connect those two with a line. And then our final line graphing problem. Let me move ourselves over here a little bit so we can have some more room. Number 11 gives us x equals negative 1. And so when you have x equals a number, that's a vertical line. And so vertical lines, the slope is undefined. Because slope we think of as rise over run. So when we have a vertical line, all we have is some rise. We don't have any run. So it's like dividing by 0. So that's why it's undefined there. So we're going to go 1, 2, 3, 4. That's good enough. 2, 3, 4, 5, 6. 4, 5, 6, 7. Keep going. Okay, so we have negative 1. And so if you think about x equals negative 1, that would be right here. And then it's a vertical line, so it is straight up and down here. So now we're on to the next part of the review sheet. And in these problems, so problem number 12, we're asked to find the slope. So for all these problems, let me actually move this down a little bit so we can write the formula. So slope, I'm going to call it M, is y2 minus y1 divided by x2 minus x1. So it's the change in y divided by the change in x. So problem number 12 gives us 2 points, 2, 4, and 3, -5. Now, it doesn't matter which one you call x1, y1, and which one you call x2, y2. But what I'm going to do is so if I just usually pick the first one and call it x1, and then the x component on the second point would be x2. And then the y component on the first point would be y1, and the y component on the second point would be y2. It doesn't matter which one you choose, you just have to keep the order the same for the rest of the problem. So, slope here is going to be y2 minus y1, so -5 minus 4, divided by 3 minus 2. So -5 minus 4 is -9, 3 minus 2 is 1, so the whole thing comes out to be -9. And we're just going to do that same thing for all the rest of these problems here. So 13, 7, -2, and -3, -9. So the slope is going to be, so again, I can label these as x1, x2, and y1, y2. And let me just kind of put this a little lower here. So the slope is going to be -9 minus -2. So now be careful. Notice it's minus a negative. You need both of those in there. Divided by -3 minus 7. And so when you do that, -9 minus -2, that is actually -9 plus 2 divided by -10. So this would be -7 divided by -10, or 7 divided by 10. So let's try another one. Number 14 gives us the points 4, 5, and 4, -9. So again, I have x1 and x2, and y1 and y2. And so the slope is going to be -9 minus 5 divided by 4 minus 4. So we would get -14 on the top, and here we're going to get 0 on the bottom. So remember, you can't divide by 0, so this means the slope is undefined. And the final one in our slopes are -2, 0, and 2, 4. So again, x1, x2, y1, y2. And so the slope is going to be 4 minus 0 divided by 2 minus -2. So 4 on the top, 4 on the bottom, and the slope would actually be 1. So the next set of problems, we're going to write the equation of a line in slope-intercept form. So there are actually, when I write the equation of the line, I do it in the following ways. So to find the equation of a line, I first need slope and a point. So depending on the problem, finding the slope might be different, and the point is any point you want. It doesn't matter which one it is. Then the second thing I do is I actually use point slope form. So point slope form is the following. y minus y1 equals m times x minus x1. And then the third thing I do is I solve for y. Now, you could solve these problems without using point-slope form. You actually could just use y equals mx plus b form. But I personally think it's easier to find point-slope form. The solving for y, this gives us y equals mx plus b, which is point-slope form. So let's try some. So problem number 16 gives us the points 2, 3, and -2, 9. So just like in the last problems with the slope, that's x1, that's x2, here's y1, here's y2. So the first thing I'm going to do is I'm going to find the slope. So the slope is going to be 9 minus 3 divided by -2 minus 2. So 9 minus 3 is 6. -2 minus 2 is -4. And I could reduce that to be -3/2. And then I'm going to plug into that point-slope form. So y minus y1 equals m times x minus x1. And the things I'm going to plug in are the x1, the m, and the y1. I'm not going to plug in for the y and the x. Those are going to stay. So y minus 3 is going to be -3/2 times x minus 2. And now I'm going to take this -3/2 and I'm going to distribute it to both of these things. So y minus 3 is going to be -3/2 x, and then -3/2 times a -2, negative times negative is positive, and 3/2 times 2, the 2 in the bottom here is going to cancel with the 2 here, and we're just going to get 3. And now all I have to do is add 3 to both sides to get y by itself. So y is going to be -3/2 x plus 6. And that is your final answer. So we're going to do the same thing with a couple more. So number 17. 17 is pretty nice. In this one, they actually gave us the slope. So m equals 4, and they give us the point, 0, -3. So again, I'm going to plug right into that y minus y1 equals m times x minus x1. And if I do that, y minus -3 is going to be 4 times x minus 0. So y plus 3 is going to be 4 times x, because 4 times 0 is just 0, so I don't have to write that. And now I'm going to subtract 3 from both sides. So y is going to be 4x minus 3. And that is the equation of the line. So we're going to do some more. So number 18. Oops, let me go back to black here. 18. Again, they give us the slope. M is -1/2. And they give us the point -2, 9. So again, y minus y1 equals m times x minus x1. So y minus 9 is -1/2 times -2. Oops, not -2. Times x minus -2. So y minus 9 is -1/2 times x plus 2. So I just simplified inside those parentheses first. And now I'm going to take this whole -1/2 and multiply it times those 2. So y minus 9 is going to be -1/2 x. And -1/2 times 2 is -1. And then I'm going to add 9 to both sides. So y is going to be equal to -1/2 x plus 8. And again, that's your final answer. 19 is another nice one where they just give us the slope. So m equals 5, and they give us the point 2, 4. So again, y minus y1 is going to be m times x minus x1. So y minus 4 is going to be 5 times x minus 2. So y minus 4 is going to be 5x minus 10. Add 4 to both sides. So y is going to be 5x, 5x, not 56. 5x minus 6. So numbers 20 and on in this section, they give us some other information that we're going to have to do to try to find the slope. So if you look at number 20, they say they want it to go through the point 7, 2. So that's my point, right? That's my x1 and my y1. And they want it to be parallel to 3x minus y equals 8. So remember, parallel lines, that means that they have the same slope. So I have to find the slope of this line here. But to do that, I have to first solve this line for y. So we're going to start with 3x minus y equals 8. So minus y is going to be minus 3x plus 8. So all I did was subtract 3x from both sides. And now what I'm going to do is I'm going to divide everything by negative. So y is going to be positive 3x minus 8. So the important part here is the slope being 3. I don't really care that there's a negative 8. I just care about the slope. So right now I've got the slope being 3, and I've got the point 7, 2. And now it's the same as the last two problems we did. So y minus y1 is going to be m, the slope, times x minus x1. So y minus 2 is going to be 3 times x minus 7. Y minus 2 is going to be 3x minus 21. So y minus 2, erase that. So we want to add 2 to both sides. So y is going to be 3x minus 19. Again, that's my final answer. So let's try another one that's parallel. So 21, so through the point -1, 3, and parallel to -x plus 3y equals 12. So again, remember the first thing we have to do is we have to put this into slope-intercept form so we can pull off the slope. So I'm going to add x to both sides. So 3y equals x plus 12. I'm going to divide everything by 3. So y is going to be 1/3 x plus 4. Remember, we're interested in the slope. So the slope is the important part, the 1/3. So now I've got the problem. The slope is 1/3, and the point is -1, 3. So again, I'm going to use y minus y1 equals m times x minus x1 and plug in what I know. So y minus 3 equals 1/3 times x minus -1. So y minus 3 equals 1/3 times x plus 1. I'm going to distribute that 1/3. So y minus 3 equals 1/3 x plus 1/3. I'm going to add 3 to both sides. So y is going to be 1/3 x. And now, to add these two things together here, I have to have a common denominator. So remember, I can think of 3 as 3 over 1. And if I want the bottom to be 3, I'm going to have to multiply top and bottom by 3. So this is the same as 9/3. So 9/3. So 9/3 plus 1/3 is 10/3. So y is equal to 1/3 x plus 10/3. The next two are similar, except instead of looking for the line that's parallel, we actually want the line that's perpendicular. So we're going to go through the point 8, 5 and perpendicular to 2x minus y equals 7. So we still have to do the same thing we did before and take this equation and solve it for y and to figure out what the slope is. Because perpendicular lines have opposite reciprocal slopes. So if we solve this equation for y, we're going to get minus y equals minus 2x plus 7. To divide everything by the negative, so y is going to be 2x minus 7, which means the slope here is 2, not 2x, just the 2. But we want the perpendicular slope. So our slope, so remember, think of 2 as 2 over 1. So the reciprocal means flip it over. So 2 over 1 becomes 1 over 2. And opposite means make it the opposite sign. So since this slope here is positive, our perpendicular slope is going to be negative. So slope's negative 1/2, and my point is 8, 5. So again, y minus y1 equals m times x minus x1. So y minus 5 is going to be equal to negative 1/2 times x minus 8. So y minus 5 is going to be negative 1/2 x. Negative 1/2 times negative 8, negative times negative would be positive. 1/2 times 8 is 4. And then I'm going to add 5 to both sides. So y is going to be negative 1/2 x plus 9. And then I think we have one more of those. We do. So 23 is similar. Again, we're going to go through the point to negative 7 and perpendicular to 5x plus 2y equals 18. So again, we're going to solve this for y. So 2y is minus 5x plus 18. I'm going to divide everything by 2. So y is going to be minus 5/2 x plus 9. So my slope, right, is negative 5/2, which means my reciprocal slope for my perpendicular line, I'm going to flip that fraction over, so 2 over 5. It was negative, so now it's going to stay positive. And I still have that point to negative 7. So again, y minus y1 equals m times x minus x1. So y minus negative 7 is going to be 2/5 times x minus 2. So y plus 7 is going to be 2/5 x minus 4/5. And then I'm going to have to subtract 7 from both sides. So y is going to be equal to, so remember, 7 is the same as 7 over 1, and I have to make a common denominator, so I want the bottom to become a 5, which means I have to multiply the top by a 5. So I end up with minus 35 over 5. That makes sense. If I divide that, that's negative 7. So negative 35 over 5 minus 4 over 5 would be negative 39 over 5. So I have 2/5 x minus 39 over 5. So the next set of problems ask us to graph systems of equations to help us find where the solution is. So for problem number 24, oops, I keep doing that, leaving it in the green color. So for problem number 24, they give us two lines, x plus y equals 4, and 2x minus y equals 5. Now, in the next section, after the test, we're going to find out how to solve these not by graphing, how to actually solve them by hand. But right now, we're just talking about solving them by graphing. So the first thing I'm going to need to do is I'm going to need to, let's call this equation number 1 and this number 2. So I need to put both number 1 and number 2 into slope-intercept form so I can graph them. So for number 1, if I start with x plus y equals 4, I could subtract x from both sides and get y equals minus x plus 4. And when we go to graph that one, we'll graph that one in red. And then my second equation, 2x minus y equals 5, so I'll subtract 2x from both sides. And then divide everything by negative, so everything changes sign. So I'll have 2x minus 5, and that one I'll graph in blue. That way we can see them a little better. So let me make an axis. Again, on the test, this is you will have graph paper, like a box to plot the graph in. So it will be easier than when you draw it by hand. When you draw it by hand, you know, my little tick marks here may not be exactly even, and so that's a little harder to make sure that everything lines up correctly. So first I'm going to graph the red line. So remember, we were graphing earlier, this is the y-intercept, and then here's the slope. So the slope is negative 1, right? So for this problem here, the slope is negative 1, and the y-intercept is 4. For this one, the slope is 2, and the y-intercept is negative 5. So for the first one, intercept 4. So I'm going to go up 4. 1, 2, 3, 4. And then the slope, right, is negative 1, which means I'm going to go down 1 and right 1. So down 1 and right 1. And I'm going to keep doing that actually a couple times so that I have a little bit straighter of a line, especially because I'm interested to see where these two lines cross each other. So I'm going to go down 1, right 1, down 1, right 1. That's probably good enough for me to get a pretty decent line. Maybe I'll put one more, down 1, right 1. So we're talking about this line here. So this is that number 1 line. And then the blue line, so we're going to go down to negative 5. So 1, 2, 3, 4, 5. And then we're going, the slope here, right, was 2. So I'm going to go up 2 and then right 1. So up 2, right 1, up 2, right 1, up 2, right 1. And you'll see right there that that's where the two lines overlap. And so that is the answer. The answer is this point right here where they overlap. So the answer, so that's 3 on the x and 1 on the y. So we're just going to do the same thing for the next couple problems. So problem number 25 gives us x plus y equals negative 3. And it also gives us that 0.2x plus 0.2y equals negative 0.3. So those are some ugly decimals, but hopefully they'll, work themselves out. So again, I'm going to take that first one, I'm going to solve it for y. So x plus y equals negative 3. So y is going to be equal to negative x minus 3. And again, we'll graph that one in red. The second line, the 0.2x plus 0.2y equals negative 0.3. So the first thing we're going to do is we're going to subtract the 0.2x from both sides. So 0.2y equals negative 0.2x minus 0.3. And now what we're going to do is we're going to divide everything by 0.2. So y, so negative 0.2 divided by 0.2, that's just going to be negative x. So our slope is going to be negative 1. If you divide 0.3 divided by 0.2, you end up with negative 1.5. So we're going to have a little bit of a decimal going on here. So that's going to be okay. And just like before, I'll graph this line in blue. So I'm going to make my axis here. Put some tick marks on it. Okay, so the red one, we're going to go down to negative 3, put a dot, and then the slope is negative 1. So we're going to go down 1, right 1, down 1, right 1 to keep getting our points. So if I went down 1 and right 1, there's 1 point, down 1 and right 1, there's a second point. And that's probably enough for me to get a decent looking line here. So our line's going to look something like that. And then the blue line, I'm going to go down to negative 1.5. And it has the same slope, so we're going to go down negative 1.5 over 1. Down negative 1.5, whoops. I don't want that point that my pen accidentally touched. Down negative 1.5 over 1. Okay, so I'm just going to connect these up to make my line. And my lines are a little like wiggly, but if you look at them, these two lines are actually parallel, and they have the same slope, right? Negative 1, negative 1. And so parallel lines never cross, which means that there's no solution. Okay, one more of these. So problem number 26. Gives us negative 3x minus 2 equals y, and x plus 1/3 y equals 0. So we're going to graph these two lines. Again, I first want to solve them for y. Now the first line is already solved for y. It just is written a little weird, so I'm going to rewrite it as y equals negative 3x minus 2. I just kind of rewrote it in the other direction. The second one, x plus 1/3 y equals 0. We're going to have to actually solve that for y. So 1/3 y equals minus x. I moved the x to the other side. And then if I divide by 1/3 and divide by 1/3, y is going to be negative 3x. So again, we'll graph this first one in red, and we'll graph the second one in blue. So let me make my axes here. Or, let's see, whoops. Get a couple points going. Okay, so in this first one here, right, I'm going to go to negative 2, and then I'm going to use that slope of negative 3. So I'm going to go down 3 and over 1, because remember, this is the same as negative 3 over 1. So we're going to go down to negative 2, and then we're going to go down 3. So down 1, 2, 3, and over to negative 1. So down 1, 2, 3, over to negative 1. Right, and I'm going to make that line. And then I'm going to do the blue one. So remember the blue one, there's no y-intercept, right? It's like the plus 0 is there. So we're going to go here at 0. And then again, we're going to go down 1, 2, 3 over 1. So down 3 over 1. And again, I end up with two parallel lines. And so since they're parallel, that means there's no solution. Our answer is actually no solution. So we're in the home stretch of the review sheet. And so the last couple that we have to do are about graphing inequalities. And so if you remember when we solved inequalities, you could get intervals to represent them. So when we graph them, we're going to get multiple answers, which means we're going to have to shade. So problem number 27 asks us to graph 5x minus y is greater than 6. So again, the first thing I'm going to do is solve for y. So I'm going to subtract 5x from both sides. So we're going to get minus y is greater than minus 5x plus 6. I'm going to divide everything by negative 1. But remember, when you divide by a negative, you have to flip the inequality sign. So I'm going to get y is less than 5x minus 6. And so now what I'm going to do is I'm going to, again, draw my graph. 2, 3, 4. I'm going to put a bunch of little tick marks here. Remember, this is my y-intercept. So I'm going to put that down here at negative 6. 1, 2, 3, 4, 5, 6. Remember, my slope here is 5, and I can think of it as 5 over 1. So from this point here, I'm going to go up 1, 2, 3, 4, 5, and over 1. So up 5 and over 1. Oops, forgot to change the pen. And then I'm going to make a line. So there's a couple notes for, kind of put them over here, notes for inequalities. If you have a less than or a greater than symbol, you're going to make a dashed line. And if you have a less than or equal to or greater than or equal to, that's when you would make a solid line. So we have a less than sign, which means we're going to have a dashed line. So this here tells us, hey, you're going to have a dashed line. So I'm going to make a dashed line between these 2 points. My line's pretty crooked. Maybe I could make that be a little straighter. Let's see if I could do a little better with it there. Oops, dashed. Looks a little better. Not a lot, but as long as it kind of looks like a line, you're all right. Okay, the other thing we have to do is we have to figure out whether you want to shade under the line or above the line. And so if you have a less than or equal to, you shade below. So I like to think of the line as an umbrella. And you want the umbrella to be over top of the person. Right? If it was a greater than or equal to, you're going to shade above. And so you want to think about a person walking on the line. right? So if you think about people, this would be a person walking on the line, right? He's kind of going up this giant hill. If you're thinking about being underneath and the line is shading you, that's this part under here. So we have a dashed line and it's less than, so we want to be under the line. So we're talking about this whole area here. And so when that shading and the dashed line, that is all part of the answer. You have to have all those things in there to give the answer. So let's try another one. I think I can make it fit over here so we still have our notes to look at. So for number 28, we're given 3x minus 2y is less than or equal to 12. So again, I'm going to solve for y. So minus 2y is going to be less than or equal to minus 3x plus 12. I'm going to divide everything by negative 2. So, and since I divide by negative, I have to flip the sign. So y is going to be greater than or equal to, oops, not negative anymore. So 3 halves x minus 6, right? Because negative divided by negative gives us a positive. I'm going to draw that number line, or that xy plane, not number line. So remember, this here is saying go down to negative 6. So 1, 2, 3, 4, 5, 6. This part here is saying that we want to go up 1, 2, 3 and over 2. So we're going to go up 1, 2, 3 over 2. And then this part here is telling me I want it to be a solid line. And since it's a greater than or equal to, I want to shade above. So I'm going to actually do that here. So I'm going to connect these two by a solid line. And then since I want to shade above, I want to be that guy walking on the line. So I want this whole area here. And that again is my answer. So let's try a couple more. So number 29 gives me 3x minus y greater than 0. So again, if I solve for y, so minus y is going to be greater than minus 3x. Divide everything by negative 1 means y, I have to flip the sign, is less than positive 3x. So go to graph this. Right, I'm going to, there's no y-intercept, right? There's a plus 0, so the y-intercept here is at 0. The slope is 3, so I'm going to go up 1, 2, 3, and over 1. So up 1, 2, 3, over 1. Because it's a less than here, right? This is saying a dashed line, and to shade below. So I'm going to make a dashed line, and I'm going to shade below. Okay, so now what we're going to do is we're going to actually graph compound inequalities. So we're going to graph multiple inequalities at once on a graph. And so we're going to graph each one just like I just did. And then we're going to look for the places where they overlap. So the first one, 2x plus, 2x plus y less than or equal to 1. So that's the first line. And the second line is that x is greater than or equal to 2y. So we're going to take each of these equations and solve them for y. So here, y is going to be less than or equal to negative 2x plus 1. And we'll do this whole inequality here in red. This other line here, first off, I'm going to rewrite it so the y is on the left-hand side. So 2y is less than or equal to x. I haven't done anything, I just rewrote it. And notice that the pointy part of the inequality was pointing towards the 2y, and that's still the same thing here. And so now I'm going to divide both sides by 2, and I have y is less than or equal to 1/2 x. And that one I'm going to graph in blue. So actually, you know what? I'll graph it in green. And then we'll make our answer in blue so it matches with the other ones. So I'm going to make my XY plane to graph these in. Okay, so the first one in red, right? Here's the y-intercept. Here's the slope. It's a less than or equal to, so it's solid. And I'm looking to shade below. So we're going to go here to 1. We're going to put the dot. We're going to count off the slope. So down to right 1. So down to the right 1. I'm going to make a solid line between those. Right? And since I'm less than, I want to think about if this were to act like an umbrella, right? I'd have to be down here. It would be up above me. So we're talking about shading on this side. Now, I'm not going to go all crazy shading like I did before because I kind of just want to see where they overlap to be able to put my final answer. But this red line would need to get shaded on this side. And now we're going to look at the blue line, or the green line. So the green line, right, remember it doesn't have any y-intercept listed here, so it's plus 0, so the y-intercept is 0. And then the slope is 1/2, so we're going to go up 1 and right 2. So up 1, right 2. It's, again, a less than or equal to, so it's a solid line. And again, we're going to shade below because of that less than. So I'm going to make a solid line here. And I'm going to shade below. All right, so if you notice, it's this area in here where the green arrows and the red arrows overlap. And so that means that this area in here, that is your answer. And so that's the part we want to shade all the way in, right? So that's the part we're looking for on our answer. So we have one more problem to try. It's another one of these systems. So 3x plus 2y greater than 4, and x minus y less than or equal to 3. So again, the first thing I'm going to do is solve each of these for y. So 2y is greater than minus 3x plus 4. Divide everything by 2. Y is greater than minus 3/2 x plus 2. So we're going to make that in red. Let's move this guy here over a little bit so we have a little bit more room, especially this is the last problem. So minus y is going to be less than or equal to minus x plus 3. And if I divide everything by negative 1, y, I have to flip the sign because I divide by negative, is going to be x minus 3. And that one, just like before, we'll do in green. So I'm going to make my XY plane here. Okay, and so for the red graph, right, here's my intercept. so plus 2. So I'm going to put a dot there. Here's my slope, right? Negative 3/2. So I'm going to go down 3, 1, 2, 3, over 2 for my second point. This here is telling me it should be dashed, and I should shade above. So we're going to make a dashed line between these 2 points. And we're shading above that line. So we're talking about this part here. For this one here, this is our y-intercept. So I'm going to go down here to negative 3. The slope would be the number in front of here. So remember, there's nothing written here, so we can call it a 1. So that means we're going to go up 1 and right 1, up 1 and right 1. So there's our second point. This part here is saying a solid line and shade above. So I'm going to connect these with a solid line. And then to shade above, you're talking about going this way. And so we're talking about trying to find where they overlap. So those arrows overlap here, which means that this area in here is in fact my solution. And so that's the end of all the problems from the review sheet. Hopefully that helped you understand more about what's going on. Remember, if you have any questions at all, you can always email your instructor, who can then also help walk you through more problems if you need them, or other problems that you've been trying. But if you can do all the problems on the review sheet without looking at the answers or without watching the video, then you should be good for the test. So good luck, happy studying, and hopefully you understand all this stuff a little better. You can do it. So just start studying and hopefully you'll do fine.